Hey everyone, it's me. You know how everything now is run by computers? Well, believe it or not, these magical machines weren't around that long ago. In fact, they used to be huge, unreliable things that only governments and large companies could afford. But over the years, they've become smaller, cheaper, and more powerful than ever before. And today, basically everyone has one in their pocket. But how exactly did we get here? How do we went from nothing to the smartphones that can fit in your pocket? That's what we'll be looking at in this episode of the Computer History series. So first off, let's look at some of the very earliest calculating devices. These are mostly mechanical devices that were invented all over the world. The oldest one we know about is the abacus. This was used as far back as 3000 BCE in ancient Mesopotamia, China, and Egypt. All of these versions looked slightly different, but all worked on the same principle. Basically, it was a frame that had rods and beads on them. By sliding the beads up and down the rods, you could count things. It was the perfect tool for adding, subtracting, multiplying, and dividing. Another device that looks very similar to an abacus is called the Antikythera mechanism. This was found in 1901 near the Greek island of Antikythera and dates back to around 100 BCE. Historians now think that it's a kind of mechanical computer that the ancient Greeks used to predict astronomical positions. For example, it might have helped sailors navigate or astronomers predict eclipses. It's not entirely sure how it works, but it likely used a combination of gears and dials to show the positions of the moon, sun, and planets. The first mechanical calculator was invented by the French mathematician Blaise Pascal in 1642. It was called the Pascaline, as you might expect. It was able to do basic calculations such as addition and subtraction. However, it wasn't particularly accurate and tended to break down quite often. It also only stored numbers for 8 digits, meaning that it couldn't really handle very large numbers. So Pascal built upon his own design to make the Pascaline II, which fixed many of the issues with the original model. In 1674, German mathematician and philosopher Gottfried Wilhelm Leibniz created his own calculator called Leibniz's stepped reckoner. This could multiply and divide as well as add and subtract, although it was still somewhat inaccurate. The good thing, though, was that it could store numbers for 10 digits, meaning that it was capable of handling much larger numbers than its predecessors. Overall, these calculators were just mechanical devices that added, subtracted, multiplied, and divided. They didn't really understand what those calculations meant. This all changed, though, when Joseph Marie Jacquard built the Jacquard loom. It was a machine that could weave cloth with multiple colors and patterns. The loom would read punch cards to figure out what pattern it should make. These punch cards contained holes in them that would tell the loom how to operate, and each card represented a single step in the process. So by putting a set of cards in the machine, you could create a complex piece of fabric. This is considered the first attempt at programming a machine. Around the same time, 2 British mathematicians, Charles Babbage and Ada Lovelace, were working on a new type of general-purpose computer. Their idea consisted of 2 machines, the first being the difference engine. This was supposed to help mathematicians calculate and print complex tables of numbers. However, this project was never finished due to lack of funding. The second machine they worked on was the analytical engine. This was a more advanced machine that would accept input through punch cards, store data internally, and then output the results by printing them onto paper. Although it was never built, Ada Lovelace wrote the first algorithm intended to be processed by a machine, making her the first computer programmer ever. Also during this time, Herman Hollerith was working on a machine that could tabulate data from the UHE census. He also used punch cards to feed data into the machine, which would then sort it and print it out. His invention led to the creation of IBM after the company saw the potential of his technology. After that, progress on computers was halted for a while until the 1930s. That was when Alan Turing came along. He proposed the idea of a universal computing machine, which was a theoretical device that could perform any calculation. This became the foundation of modern computers. However, he never actually built a machine like this himself. The first programmable digital computer was built in Nazi Germany in 1941. Its name was the Z3. It was built by engineer Konrad Zuse. It used movable gears and binary code, which is the system of storing data as a series of zeros and ones. The reason why it was programmable was because it used punch tape instead of the punch cards that previous machines used. Unfortunately, the The Z3 was destroyed in an air raid towards the end of World War II. However, another machine that was built during the war was Colossus. This was a British code-breaking machine that was built in 1943. It was used by the British government to decrypt messages that were encoded by the Germans. This was a very important role because it helped the Allies win the war. Colossus used a type of vacuum tube for processing data. This allowed it to perform calculations much faster than any previous machine. It also used a type of memory called a mercury delay line, which allowed it to store vast amounts of data. These innovations in hardware allowed Colossus to be one of the fastest computers of its day. That title, though, would eventually go to the Electronic Numerical Integrator in Computer, or ENIAC. It was the first general-purpose electronic computer. It was built in the United States in 1945. The ENIAC was massive and weighed 30 tons. It used 18,000 vacuum tubes for processing data and took up a room the size of an apartment. It was originally designed to calculate artillery firing tables for the U.S. military. However, it was later used for a variety of other purposes, such as simulating the behavior of nuclear weapons. For a while, these large mainframe computers were the only type of computer that existed. They were expensive and difficult to operate, so they were only available to large organizations like banks, governments, and universities. The average person couldn't afford one, let alone operate one. But during the 1950s, that would begin to change. These computers were so big and complicated that they required a team of engineers to operate them. They were also very unreliable and prone to crashing. However, the 1950s saw a breakthrough in the miniaturization of computers with the invention of the transistor. This is a small semiconducting switch that could be turned on or off, allowing data to be stored and processed. By replacing vacuum tubes with transistors, computers could become much smaller, faster, and more reliable. The first commercial computer to use transistors was the ENIAC one. It was built in 1951 and was purchased by the U.S. Census Bureau. It was used to process the 1950 census and was even able to predict the outcome of the 1952 presidential election. The accuracy of the prediction shocked many people and led to the ENIAC becoming a media sensation. This helped to popularize the idea of computers and showed that they could be useful for more than just complex calculations. After that, it was only a matter of time until computers became commonplace in businesses. In 1964, IBM introduced the System 360, which was the first family of compatible computers. This meant that businesses could upgrade their systems without having to make major changes to their software. This compatibility made it easier for businesses to adopt computers and pave the way for the IBM PC in 1981. This brings us to the time when computers went from being something that only businesses and governments had to something that anyone could own. Computers became smaller and cheaper, and eventually became powerful enough to be put in phones. The first personal computer was the Altair 8800, which was built in 1975. It was sold as a kit and cost $350. It inspired two young programmers, Bill Gates and Paul Allen, to create Microsoft. Then there was the Apple I, which was built by Steve Jobs and Steve Wozniak. It was the first personal computer with a user-friendly interface. This made it easy for non-programmers to use and opened the door for computers to be used in homes. The IBM PC followed in 1981. It used the operating system called DOS, developed by Microsoft. It became the standard for future PCs and paved the way for the mass adoption of personal computers. At this point, computers had gone from being giant, expensive machines to being affordable devices that could fit on your desk. They were still primarily used for tasks such as word processing, spreadsheets, and playing games. But the real breakthrough came with the Graphical User Interface, or GUI. This was first developed at Xerox PARC in the 1970s. It featured icons, windows, and a mouse, which made it much easier for users to interact with their computers. Apple was the first company to bring a GUI to the mass market with the Macintosh in 1984. This made it possible for people to use computers without needing to know how to code. As time went on, computers got smaller and cheaper. They were eventually put into laptops and then smartphones. Today, computers are everywhere. They're in our cars, TVs, refrigerators, and even toothbrushes. We use them for work, for play, and to stay connected with friends and family. Computers have become an indispensable part of our lives. So where do we go from here? What's next for computers? The truth is, no one really knows. Some experts say that the next big thing will be artificial intelligence. This is when a computer can think for itself and perform tasks that would normally require human intelligence. Others say that the future of computers lies in quantum computing. This is when a computer uses the principles of quantum mechanics to perform calculations. This could potentially allow computers to solve problems that are currently too complex for even the most powerful supercomputers. Still, others say that the future of computers is in brain-computer interfaces. This is when a computer can communicate directly with the brain. This could potentially allow us to control computers with our thoughts alone, no matter what the future holds. One thing is for sure, computers will continue to play an important role in our lives. They've come a long way from the abacus to the smartphone, and who knows what the next era of computing will bring. I hope you enjoyed this video. If you want me to cover any of these eras in more detail, just let me know. Thanks for watching and see you next time.